goofball. All right. We are going live. I have a cat in my lap. What's up, everybody in the chat room? Ben, Benjamin, HR, Brian, Curtains, everyone else who made it. How you doing? This is Voltage Control Lab. This is Xena. Oh, don't hit that. I'm Joe. We got all the cats in the studio today. We even have Elements Cat, the GIF, bouncing around on screen. Hopefully that stays animated. We'll see if it actually keeps on going. I've noticed problems with the animated GIFs in this streaming app. So here we are, Voltage Control Lab, voltagecontrollab.com. This is Mod City Live. You can check us out on Twitter at vcontrollab. You can check us out on Instagram at Voltage Control Lab. You gonna purr into the microphone? You're a good boy. My name is Joe, and I'm a producer and educator from Los Angeles. I teach at Musicians Institute in Hollywood and Icon Collective in Burbank and online. And I guess we're all online now. But yeah, here we are. Welcome to Voltage Control Lab if this is your first time. Big shout out to Make Noise for helping to get the word out about the maths show. Love the people at Make Noise. They're great people. And they've been very generous and gracious to Voltage Control Lab. So I can't say enough about Make Noise. And even if they had told me to F off and leave them alone, I would still say thank you to Make Noise because they make such amazing stuff. So we're getting into maths today again. If you missed yesterday's show, go check it out. We talked about using maths for the most part with very little input, using it as a LFO, as an oscillator, as a function generator, in a sense, as a complex oscillator. We talked about sending musical sequences into maths, right? We cycle a channel on maths, either channels 1 or 4 or both maybe, and we speed up the rate to audio rate, or maybe you just want to sequence and change the tempo of your LFOs. That works too. We can modulate using that both input, the rise and or fall inputs. We noticed that those have an opposite reaction to incoming CV. And we started to look a little bit at the mixer section of maths, the center area where we can start to mix together signals, where we can control the amplitude of the signals that are coming out of maths, and even using it to a degree as there's another cat back there, using it to a certain degree as a signal mixer, attenuverter, all of these things, right? The nice thing about maths is that we have multiple channels of CV generating and or manipulation, and they can all mix together. We can use them independently, but we can also mix them all together all at the same time and get some really interesting and complex modulation sources. So yeah, OCoast, one of my favorite devices, one of my favorite synths of all time, I have to say. And cat hair in my coffee. We did a show on the OCoast a couple of weeks ago, and I think I owe you guys another show on the OCoast, specifically about the options and the expanded functionality with the arpeggiator, with the MIDI, with the hidden LFOs. if you want a quick primer on some of that stuff, you can go back and check out some of our older OCoast videos. And we did a bunch of videos with the OCoast when it came out. One of my favorite devices. Are we too low? Is that my problem? Maybe that's better. Tell me if that's too loud, too soft, whatever. We got a cat pile behind me over there. One cat trying to horn in on another cat's territory. We'll see how that works out. Oh, oh, there's a battle. Oh, okay. Well, Xeno won. Moog left. Okay. Well, all right. Just a couple of things to mention. Ableton is doing a free 90-day trial. So if you're looking to learn Ableton, there's not been a better time. Okay, thank you. I'll turn it up a little bit louder still, and we'll watch the modular level when it comes in. They weren't really fighting. They don't really fight. They're grandmother and grandson cats. So Astro Fish, what's up? Ed, good to see you. Nicholas, hope I'm pronouncing that right. What's up? Grant, great to see you as well. All right. So let's do it. What was I saying? Oh, yeah. Ableton, 90-day trial. If you want to learn Ableton, we could do some Ableton lessons in here if anyone has any interest in that. Or maybe we could just do an Ableton CV tools chat, right? A lesson on the CV tools inside of Ableton. If you have an audio interface that's DC coupled, like the ES8 or the ES9, or there's a number of additional audio interfaces out there that are not modular specific. Motu makes a number of those devices. I believe the Focusrites, the whatchamacallits, there's a bunch of them. There's a list online, so you can go and find that. I think if you look on the Expert Sleepers website, they have a list of audio interfaces that are compatible with their software and DC coupled devices. So what does that mean? It means that you can send LFOs, stepped sequences, things like this out of your audio interface channels, which generally in the past, audio interfaces have been AC coupled because they generally assumed you'd never want to send a direct current out of your audio interface, which typically is going to be routed to your speakers. And a DC signal going to your speakers could burn it out, could destroy your speakers. So there's a reason why not all audio interfaces are DC coupled, but it's becoming another kind of function du jour with the popularity of Eurorack and the resurgence of modular. So you can check on your website, or your audio interface website, or wherever you can find out this information. You might have to even send a message to technical support. Though, as a former tech support agent, I would encourage you to look anywhere and everywhere you can before contacting tech support. Those poor souls are inundated with insanity all day long as it is, and we'd all be better if we never had to contact them and could leave them alone to listen to their streaming shows and the things that they would prefer to be doing. So we'll all be better for doing that research on our own, but worst case scenario, you can always ask your audio interface manufacturer what the deal is with your own audio interface. So yeah, I see some CV tools fans in there, so maybe we'll take a look at that one day. But this week, we're getting into maths. Yesterday, again, we went into LFOs, oscillators, things like this that we can perform with maths, that we can use maths in a sense as all of these things. a creative oscillator, if anything. Today we're going to be talking about um, losing my train of thought here. Envelopes. We're going to be talking about rising and falling uh, um, modulation sources, how we can maybe in a deeper sense conceptualize the way that maths manipulates CV and provides us with opportunities to tweak timing, to tweak CV sources from outside of the DAW, and maybe generate some other oscillating signals. HR, glad you noticed the mutable elements Nyan cat. I just tweaked that last night. So, excuse me. Okay. Benjamin, by the way, we did a clouds episode a couple of weeks ago, a granular synth episode. I think we did a specific one about clouds as well. We did do kind of a basic overview of the OCoast and, all of those things. And I see we have a lot of former or current tech support people in there. And my heart goes out to you. At least you get to work from home. Hopefully, it's not so bad when you don't have to sit in a call center full of phones ringing all day or people yelling at each other, or as the case was when I was working at Native Instruments, people shooting rubber bands at you or blasting um, granular synthesized tuba samples at you or throwing yoga exercise balls at your back while you're trying to talk to a customer. But we deal with what we have to deal with in that tech support world. And I'm glad to be out of there. But uh, it was some fun times, I have to say. All right, well, let's get into some maths. Let's take a look over here at what's going on with maths. Okay. So, yesterday we were kind of letting maths run on its own. We were cycling channels and seeing, hey, what can maths do without any signal patched into trigger it or what have you. I'm going to turn on one additional modular case here just in case we need it. So today we're really going to start looking at triggering and sending CV signals into channels 1 and or 4, where we have the ability to manipulate that incoming signal. So on this oscilloscope, we should be kind of seeing this bouncing gate signal, and maybe what I'll do is switch it to 2 volts. So it's a little bit more pronounced. We can maybe see that a little bit better now. So in the red, we're seeing an incoming gate or trigger, a pulse really. It's not really a gate because it's not lasting very long, but that's all right. We're going to take that signal and we're going to route it into the trigger input on channel 1. We are not cycling, though we could enable cycling while we're triggering this thing, but instead we're just going to trigger this out of cycle mode. And when we do that, we'll then patch the unity output down here at the bottom to channel 1. And you see it's a green indicator there. So we've got an incoming gate or pulse signal. It's really just a pulse that's going 5 volts, up to 5 volts. I think it only has to go above a rising voltage going above 2 or 2.5 volts to trigger maths. But our common amplitude for triggers and gates is probably going to be 5 volts. Some might send 10. I think, in fact, yeah, the maths end of rise or end of cycle gates will send a 10 volt gate signal. But we're going to take that trigger signal And when we, of course, trigger our channel on maths, channels 1 or 4, we're going to get something that looks like an attack decay envelope. Now, what is that? Well, as that rising signal is seen coming in, we get a rise. It basically starts our rise and our fall time. Okay, we rise over a certain amount of time. That's our attack stage. And then we fall over a certain amount of time. That's our decay stage. And how we set the rise and or fall times determines the shape of that envelope. Fast rise, longer fall gives us this sort of sawtooth shape. A longer rise, a faster fall gives us a ramp shape. And if they're closer to the same setting, the same length, we get something that looks more like a triangle shape. So it doesn't matter what we send into this trigger. It could be a gate, it could be a pulse, it could be a square wave from an oscillator, right? This is an incoming, looking for an incoming rising voltage from 0 to some sort of positive voltage, right? That happens almost instantaneously with our pulses and gates. But that's enough to trigger this rise and fall on maths. And just like we saw yesterday, as we start to turn this vary response knob at the bottom, we start to change the shape of that rising and falling voltage. Right, as we go towards the exponential side, we get this slower swooping upward. We're extending, or sorry, we're shortening the length of the overall attack decay envelope. Notice it's very short compared to the gate. As we go back towards the linear position where we are now, you can see the rise and fall times flatten out a bit. We can maybe shorten those a bit. And then as we go towards the logarithmic side on the vary response knob, we get this more rounded hump. It elongates the length of the envelope. We get much less pronounced peak, humping up and then back down to that 0 position. Let's unmute this for a moment. Let's see if this is loud enough to hear. That's a little bit less aggressive. Is that too loud? Is that loud enough? Looks like it's kind of loud. You guys let me know. Okay. As we increase that rise time, the vary response knob, of course, controls the bending shape of our rise and our fall time, and it controls the length of those rise and fall times. If we make this long enough, we'll notice that we re-trigger the envelope before it even gets to 0. It never really even goes down to 0. It gets re-triggered while it's still high, it starts to rise again. And of course, yesterday, we were experimenting with putting, what's up, Alex? Good to see you. Down 10% maybe? Okay, let's turn that down just a little bit. Okay, we can modulate the rise, fall, or both inputs with, let's say, a sequencer. Send a Lock over here. Get some random sequences going. And we can send in a sequence to control, let's say, the fall time. Let me know if that level is any better. Looks a little bit more reasonable now. And we can see now that the lengths of these envelopes are changing. We can hear it, of course. Do the same with the rise time. We're dealing with a very short amount of time here. If we maybe go halftime here. Very slightly modulating that rise time. Could do both. Oh, we're going to the trigger now. Let's go to, or into the gate input. Let's use the trigger, and that's what we want. I can't believe you guys are talking about grayscale panels on this make noise work of art, right? This, to me, of course, we have to learn what this interface is representing, but the visual of the Make Noise brand is half of the fun to me. But you know, more power to you. I'm not gonna bash you for your life choices here. Okay, so let's think about this. Let's try, instead of using the trigger, let's use a longer gate source. Now, what could that be? Let's take a square wave instead of a clock. Okay. Patching into the Tip-Top Z3000 now, which has a nice big fat square wave. I'm going to go nice and slow. Okay. So if we stay in the trigger input, doesn't so much matter what the rising input actually does, right? It doesn't matter if it's a pulse, a gate, a square wave, or anything. It just matters that that rising edge is coming in and triggering the rise and fall, starting that rise and fall process. Now, if we instead send that into the signal input, that's the one with the arrow going into it, instead of the one that we were just patched to, which says trig on it, trigger. Okay, that's looking for pulses, or really just the onset of the gate or pulse signal. The CV signal input, that now is going to care how long the gate stays high. Meaning, if we send this in, our envelope is going to start to look a little bit different now. Now, as long as that signal stays high, as long as it's a gate, that signal is held. So we rise, we hold and sustain specifically at the top there, and then we fall. Now, Now, of course, we could recreate that rising and falling shape. Of course, this is a unipolar signal. The square wave LFO, you can see, is bipolar. It goes into the positive and into the negative. But our resulting envelope shape, our revolting envelope shape, our resulting function rises from 0 and comes back to 0. So as we raise that attack time, you can see it softens the onset of that gate. We can think of that as a kind of a fade in. And then the fall time softens the release. So we can see that sort of relationship between square wave and envelope here. Square wave in red, the envelope in green, right? Now, of course, we're coming out of the unity output right now. This gives us a 0 to 10 volt rise and fall signal. If that's too much for us, let's say we're using a VCA that only needs 0 to 5 volts, we might come out of output 1. Then we can use the number 1, the channel 1 attenuverter to control the amplitude of that rise and fall. And we can invert that signal. I think we're offset slightly here or something. Okay. Oh, look at that. Actually, we're getting a bipolar signal right now because we're using a bipolar square wave. So excuse me, I was confused. Notice that we have a bipolar LED here. It indicates green for positive, red for negative. And with our trigger input, it doesn't care if it's a bipolar signal. With our signal input, you can see it's actually going above and then below that 0 point, right? You can see there's the 0 point. But now, with the CV signal, we're actually doing a bipolar manipulation, right? It's following that incoming signal, and it's softening that attack and release stage. But if we use the channel 1 attenuverter input, still bipolar, controls the amplitude of that bipolar signal. It looks like it's smaller, but it's actually because that signal is 5 volt range. Okay, there we go. Now there should be the same range. So it's really just recreating that exact same signal, especially if we come out of the unity output. if we use that channel 1 output, then we can attenuate that signal, and it won't be the full range. And in fact, we can also invert that signal so it goes into the negative when our square wave goes into the positive. Just inverting the entire shape. In fact, here we can get kind of the exact inversion of that square wave. As close as we can get here. Okay. We also have the end of rise square wave. That's going to always be a 0 to positive range, 0 to 10 volts. You can see it's following the exact same shape. And if you notice, when we turn up the rise time, coming out of the end of rise on channel 1, when we turn up that rise time, we delay the onset of the gate. See, as I bring up that rise time, the green signal is going to start to delay after the gate coming from our square wave. To the point where we shut it off. What if we change the fall time? Extends the length of the gate. Changing the pulse width of that square wave coming out of our end of rise. If we cycle this and turn up that rise time, not much difference. Let's send this into the trigger input. Okay, so here's back to a end of rise square wave. And if we elongate the fall time a little bit, we can see we can recreate a gate very similar to that. Now if we increase the rise time, we can get a kind of clock divider. 12. Yeah, we can get an asynchronous clock as well. Okay. So, if we send a gate into the trigger, we get a rise and a fall. If we send a CV signal into the signal input, we get a rise, a hold, and a fall. So, we've been doing this with gates, square waves, pulses, things like this. What if we do that instead with a sequence? Let's consider what was happening there, right? When we go from 0 to 5 volts following this gate, the signal input allows us to use the attack and the rise and the fall time to smooth out that rise up to 5 volts, from 0 to 5 volts, to smooth out that fall separately from 5 volts to 0 volts. Well, what's a gate? It's a briefly held direct current at either 0 or 5 volts or 10 volts or whatever volts, right? So, what other direct currents do we have access to? Musical sequences. So, if maybe we replace this incoming signal, that square wave, with a musical sequence. What's going to happen now if we patch that sequence into our signal input? Well, excuse me, first things first, let's take the output here from maths. Let's send it into something that will respond to the sequence, like the volts per octave input on an oscillator. And we'll turn the pitch down on that thing because that sounds like it's going to be squealing. Okay, let's try it out. Let's see. Whoa. Okay, and of course... Let's make sure we got that signal. Oh, okay, we're coming out of the end of rise output. We're going to come out of the unity output. Okay. So, now we're taking that signal and we're passing it through the maths channel with no attack and rise and fall time, right? So we're getting something that should sound pretty much like that exact incoming signal. In fact, we can't even see the red version of the signal because the green is overlapping right on top of it, right? So the red signal coming in there is, if you can see that, is our musical sequence, our note sequence. Okay, it's the same thing we're sending into the CV input now on maths. So with our rise and our fall at 0, fully to the left, we're going to get something that looks an awful lot and sounds an awful lot like that same sequence. Sorry about that. Let's try this. Okay, that might be a little bit better. Easy to patch an ADSR, not so easy per se, but we can do it. So I think we're going to do that on Thursday, actually. But when we start doing a little bit more inbreeding between these channels. So we got that signal coming in, And look, it doesn't look like a square wave, right? It looks like steps, like our sequence typically will look if we look at it on a oscilloscope. It's held currents, right? If we made a sequence and they didn't have direct held currents like that, or we played a keyboard and we played a note and it didn't hold nice and flat like each of these notes is, then we get a weird pitch dip or change for every note that we play. That wouldn't be so nice, right? We want the held notes so that we can hear that note playing, that noticeable pitch, right? And so we can do this. However, incoming signals can be smoothed out. If we raise the attack time, or the rise time, I should say, now what does that sound like? You can do the same thing with fall time. Or we can do it with both of them. And of course, the vary response knob will affect the curvature of those rising and falling slides, gliding effect. And of course, shorten those rise and fall times if we go to the exponential side, and elongate them if we go to the other side. If we're working with faster tempos, we might push it a little further to the exponential side. That way we have a little more real estate. So we don't get the handy digital soft synth feature or option to be able to control glide time on a synthesizer in the modular world. We have to use something of this nature, which we call slew limiting, Portamento, right? This is smoothing out, just like we were with the attack and decay or release times on that square wave. We're smoothing out the sudden change from one held direct current to another. The rise controls upward motion, right? If we move from a lower step to a higher step, the rise time will control the glide up to those higher notes, right? Anytime we're moving from a lower note to a relatively, comparatively higher note, that's when the rise time affects the slew or the glide or the portamento, right? I know exactly what you mean, Alex. I'd like to limit your slew too. No, I'm just playing. The fall time controls downward pitch movement. If we're moving from a higher note to a relatively lower note, then we get slew limiting on that downward motion by using the fall time. And you can see, you can dial it so high that it smooths out everything. on our DAW or our synthesizers on our DAW, we're usually going to have the option of scaled timing of glide or portamento, meaning when uh, when we jump from a very low note to a very high note, it will take as much time to glide all the way up there as it would a note that was a semitone above the previous note, right? But we don't get that scaled effect here. We don't get this doing its effect of an equal amount of time for glide, regardless of the distance of the notes. Here, I guess we do get the scaled effect, right? We are getting the effect of a rising and falling glide time that's longer the further apart those notes are, right? The further that we have to rise from one note to the next or fall from one note to the next, the longer it's going to take that slew limiting to achieve that. Now, we might be able to use the incoming sequence and maybe mult that sequence to the rise or the fall time to change that relationship. But right now we're starting to get into using one signal to do a few different things that might start to get a little bit confusing, have to do a little bit of experimentation there. But, when we're dealing with a smaller system, this is what we have to do. A mult is a very valuable thing in a small system because a little bit of modulation can take you a lot further with a mult. Um, Shout out to Hosa for these funky, what do they call these? Knuckle bones or something like that. Um, I got a qubit one around here too. I don't know what I did with that. It's around here somewhere. They were giving those away at NAM, the qubit ones. So shout out to Qubit. Oh, here it is. Duh, right in front of me. There's the qubit one. These are malts that free up your your space. Now, buffered malts, of course, are malts that are powered, especially useful for maintaining pitch sequences, quantized pitch sequences, especially. Quantized pitch sequences, of course, if you don't know what that is, those are, for instance, a sequence that fits into a semitonal musical relationship, right? Um, Again, something that we take for granted in the DAW soft synth environment, where everything is following a semitonal pitch relationship, and we fight with it to make it do something more interesting and musical that might sound less rigid in a traditional sense. But in the modular sense, we kind of have to work overtime to make our sequences follow a scale or a chromatic scale, even. Um, and A buffered mult helps to support the voltage levels and maintain very accurate voltages so that if we send a controlled scale based sequence into that buffered mult, we get the exact copy of that signal back out. So we could use one sequence that's following a scale and is very traditionally musical in a sense, and sequence a number of different modules with it without any signal loss. That's where things start getting a little bit weird when there's some signal loss from a mult. And if you can imagine sending a signal into one of these inputs on a non-powered, a passive mult, as we call it, um, a signal goes in, a signal comes out, and if we start patching other outputs to other places, that signal coming in starts to dip in voltage, right? Its highest voltage might not be as high as it's supposed to be anymore. It might lose just a little bit of voltage. I suppose it could potentially lose a lot of voltage if there's something really going like haywire. It should be pretty minimal though, and in most cases, a passive mult is just fine. If you're trying to get very accurate performance and pitch relationships, then a buffered malt is really important. But almost any other signal inside of the patch, inside of the modular world, a normal passive malt will do fine. And you can build a passive malt very easily by, oh yeah, Alex is saying right there, would be good to learn DIY buffered malts. That would be a little bit harder, but the passive malts are super easy. You just need some jacks, the same kind of like little electronics, 1/8 inch mono jacks that you'd have built into every one of these modules. You can buy those on Amazon or eBay or an electronics store for relatively cheap, and a blank panel, right? And we can just drill a couple holes in the blank panel and solder things together on the other side. Super easy to do. There's tons of, I think, little tutorials on how to do that. It's like the easiest DIY build from scratch that you can do. And if we were to look at a normal passive malt module, you'll see it's just the same inputs and outputs connected, soldered together with one wire all the way across. The manufacturers might include a PCB to perform that functionality, so it looks a little less messy. But a buffered malt takes a little bit more attention because of the power involved, and yeah, maybe I'll look and see if there's a buffered malt DIY instruction guide. Maybe we could do that together. I do have some build ideas for us to do on future shows, but we'll deal with that when we get there. VCAs, passive VCAs were one of those things. Homemade Vactrols, that type of thing. So, it's a complicated universe, the modular world, and but even something like this, I would go so far as to say this is modular. You don't need to worry so much about buffered signal support in most cases, unless you're really trying to do some very lyrical, very traditional sounding sequencing. You can get away with passive malts just fine. It might even sound a little bit more modular and a little bit different than everything else, which, it all comes from the DAW these days, and that might seem kind of boring at times. So, no beef on the DAW, but just saying, something to try out and not get too concerned about if you don't have a buffered malt. So, let's think. Where are we going with this? What next? What else can we send into this thing to modulate these signals? Well, let me bring up my... I do not have classic solid state fate stuff, but we could, this is something we could do on Friday. Friday our shows are Q&A and sound recreation day. So for all of you folks who are new to the show, tomorrow actually we're going to do a live production session. We'll pick up more with maths on Thursday and Saturday, but Fridays we do live Q&A, so we could take a look at those modules at least. I don't have them, but we can look at them together. We could try to analyze and figure out what's coming out of those things, how we could best use and utilize those modules. Or if you just want to buy me a couple modules. Just kidding. What was I going to say? Yeah. Thursday and Saturday we'll continue with more maths stuff. And But Q&A on Friday, great time to do that. Also, if you have any sounds from tracks that you like, tracks that you want to know how the F did this artist make this sound, we do that on Friday as well. So if you bring some links or send me some links in advance, I don't listen to them in advance. I'll tell you right now, this is half the fun of it for me, and I think for you is the struggle, the challenge of it. So I don't listen to the examples that you send in advance, but um, the yeah, sorry about the Ableton shirt. Not trying to. I'm not an Ableton certified trainer. I'm not represented by Ableton, but um, the it's actually Elements Cat Nelson, by the way. The uh, uh, the whole idea on Friday is you guys submit some song ideas to me, not song ideas, sounds that from songs that you like or pieces of music that you like, and we will reverse engineer them together in real time. If we can do those on modular, then maybe we'll do them on modular. Sometimes we have to do them in the DAW. There's certain sounds that are just hard to do on a modular or impossible to do on the modular. So the 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 bigger picture here is that if you guys have any kind of questions that you want to talk about, any Q&A type of shit, I I don't mind what it is, whether it's I mean, let's keep it somewhat music related, but yeah, Fridays are day for that, and that would be a great time to look at some of those SSF modules and try to demystify those things, even just from a visual. That's I think a useful thing. VCV rack might work. I always 100% back VCV rack. It's really cool, and for most of us, um, that's what that's what we have access to. For a lot of people, that's how we're going to get into modular. That's how we expand the functionality of our modular is through VCV rack, through maybe Reactor, things like this. And if you guys know any maths like modules in any of those systems, let us know so we can pass it along to our friends who are VCV rack folks here. Um, you can submit sounds that you made and pretend you don't know. That would be tricky of you. Um, Bitwig fans, I see. Um, love Bitwig. Good friends of mine. They've brought me along to NAM the last couple of years. Can't thank them enough for that. Not working, thankfully. They've got plenty of people handling that. But uh, the Schwangel stuff. Ah, interesting idea. We had Ben Cantil, also known as Encanti, on the show 2 months ago. Fuck, it's almost 3 months ago now. We had him on. Um, I would highly recommend you guys go check him out. He actually played at Schwangel's last run of shows at Red Rocks. He was doing their live playback and effects and things like that. Um, I think his uh, musical partner Zebler from the two of them together make up the Zebler and Conti experience. Two old buddies of mine. Zebler, I believe, did visuals on that show, so we got some Schwangel family in our extended family. Um, let's see. I couldn't get into VCV rack. Yeah, I can understand. It's uh, it's the type of thing though, especially again with a DC coupled audio interface. It can blow the functionality of a hardware modular synth into overdrive, right? Like taking it up so many notches. Sorry, I got coffee burps. Um, Rampages in VCV. Oh, okay, that's pretty close. That's very similar. That would be a good one to look at a certain point. I think someone was Rampage. Um, so yeah, what else? Alex, to answer your question, I do not have Patreon. Should I get on Patreon? Should I start a Patreon? I've thought long and hard about it. I think that's something. It seems like a good place to be doing sound recreation type of videos because on YouTube, there's a little bit of a well, on most of these services, there's a bit of a challenge in regard to um, copyright claims. I got one the first week we did this, doing a Joey Beltram track. And, if you're familiar with YouTube, you know how complicated the copyright nonsense is. If you're on Twitch, it's crazy there. Um, we have not had Verbose on, though our good friend Ryan Powers works with Verbose quite a bit, and he's local in town. He's a local LA artist and all around awesome dude. And so we are hoping to get him on the show in the near future. But, you know, this whole social distancing situation is making it a little hard. Um, so yeah, maybe I'll get onto Patreon. I've been kind of holding back on it, especially since the our current times started kicking into gear because I'm not necessarily right now the one who needs your Patreon dollars. I would love to just you know collect it all and you know put it all in my pockets, but um, I'm still I'm still working right now. I have teaching gigs um, and school. We're on break right now, fortunately. That's made it a lot easier to do these daily shows. But I felt it was kind of incumbent on me to stay out of the way of all of my friends and colleagues who have lost a lot of work for the foreseeable future. One of my good friends, LPG, LPGOB is her name. I'll type that into the chat here. Um, LP is one of my uh, fellow producers. We produce a ton of stuff together. We've produced a lot of LPGOB tracks together. And she is the opening DJ for Sophie Tucker, another couple of good buddies of mine. And Sophie Tucker was about to go on a 3 or 4 month long world tour that was supposed to launch the beginning of March. And um, that got blown away. And now I don't think anybody's looking to tour or even can effectively schedule touring until 2021. And even then, the whole thing is going to be thrown for a serious loop because all of the people who work in the industry doing booking, doing artist management, doing the actual artistry themselves, they may or may not be in the game by 2021. Shit's going to change. So, and then you have to also consider what about the venues that they would play? Who's booking those venues? Those people are out of business too. So it's a really messy time right now. And, you know, I feel like uh, Patreon would be a great way to do and structure certain things. But at the same time, this isn't a time that's about me per se, and I don't think I need to be sticking my nose in other people's income streams, if you know what I'm saying. However, um, we are going to keep doing these every day, except for Sundays, mind you. And oh, look at that, Benjamin does live streaming for concerts and live events. Every event was canceled. Yeah, I mean, it's not just music either, right? It's not just artists who are out of business right now, and um, I think that's where it really kind of hit us all was when even sports shut down. That's where the really big money is. But um, uh, that's why I decided I would do this because this is at least something that we can all do. Not to go too far down this like let's bemoan all of this shit because that's easy to do, and I'm trying to largely distract us from that. But uh, nonetheless, this is a time when we all have access to our gear or whatever gear we have available to us, and so um, we're trying to make of it what we can, and keep our community alive and thriving and happy and together. And so that's kind of where I see this whole show hanging right now. So we're gonna keep that going. Next week, um, um, I start school again, so we might have to find a different time of day to do this live stream thing. Um, but maybe I'll put a poll on our YouTube community page and see what people say about what times would be good. Um, another, since we're talking about it, and I'm really interested to hear what you guys think about this. We're going to keep doing the normal live shows. That's going to keep on going. Again, might change hours as of next week, but we're going to keep it happening. In addition to that, one idea that I have had is to start doing maybe not daily, but um, maybe once a week music business conversations, Q&A, things like that. But um, while I play video games. So, the easiest way to interact, I suppose, would be to jump in with me on like PS4 or something like that, and I'll also take questions via Twitter or Instagram or whatever it might be. But that way, I can get in my video game time for the day, and we can still talk about music related stuff, and we can play video games together if you want to get in on it. And um, I don't know if that makes any sense whatsoever to anybody, but you know, trying to keep it fresh a little bit here and do some stuff that I think would be fun as opposed to just like talking at you for an hour and a half every day. That would not replace this show. That would be like in the evenings, probably. What are you on, HR? If not PS4, what do you guys use? PC? Do you guys PC gamers? Are you Xbox? Um, make some synths in dreams. Is that a game? We used to make synths in Second Life. I guess we could all congregate in Second Life. That might be weird, but I don't know if you guys know what Second Life is. Another thing from another time, I guess. Oh, Benjamin's a gamer. I can see. Okay, well, um, PC. Okay, that gives me some information. I don't have a good controller for PC. Dreams has a whole DAW in it. Is Dreams? Oh, it's a PS4 game. Is that a VR game? I'm looking it up right now. Dreams game. Oh, look at that. That's pretty cool. Whoa, that's a weird game. That looks really cool. Xbox One, Switch. I have a PS4, but no idea how long it's been unplugged. Well, this does give me some things to think about. Almost just about every retro game, even all of the text games. Do you have Oregon Trail? It's like that's pretty much the only game you ever need. Poop died of dysentery. That was my favorite Oregon Trail quote. We would always name the characters Poop and Ass and Butt and things like that. So, you know, Poop broke a wagon tongue, or Ass died of dysentery, that type of thing. If you guys don't know what I'm talking about, look up Oregon Trail. um, so, Zork. I don't know what Zork is. Is that a game too? Um, well, all right. I'm gonna crank away on that idea because I think it's a good idea. I think it would be fun. Uh, and another great way to escape the mundanity of normal everyday um, replaying of the games we've played a million times. And, it might be fun to talk music and business in that type of an environment. Might be a weird diversion. So, yeah, everyone should know about Oregon Trail. Um, it's like Red Dead Redemption, but with way less options. um, all right. Well, tomorrow we'll get into way more maths. Or no, wait. Tomorrow we're going to live produce a track. And last week someone suggested we do lo-fi. We could do lo-fi hip hop, lo-fi house. We could do lo-fi drum and bass. Somebody suggested make a drum and bass track with kitchen samples. Um, I would have to probably use samples from a library of kitchen sounds that I should have, but because I don't want to go around sampling kitchen sounds while we're on the live stream. Really, I think that would be a difficult thing to live stream. You guys would be sitting here while I'm walking around my kitchen, but all of those lo-fi death metal. Ooh, that might be interesting. I don't know if I can pull off the death metal voice, but could work a little death metal in there. Well, whatever comes out tomorrow, we'll see. We'll do a live production session. I'm gonna try to do a whole track in an hour, hour and a half, something like that. Lo-fi makes it maybe a little bit easier because, especially lo-fi hip hop, the sound, the tracks are usually pretty short. But lo-fi house is pretty cool too. What are decent sources to build a sample and loop library? Anything free, Brian, is what I would say. Now, I mean, what I would suggest is if you can trade libraries from people, you trade the collection that you've built up with the collection that someone else has built up, and you both benefit from each other's collections that way. Um, CDM, Create Digital Music, which you can visit at cdm.link, is they just had an article today about the Ryman Collective. Is it Ryman? Ryman? I think it's Ryman. I think they're German. But they are a collective of producers who make sample libraries, and they just released a number of free ones that are available, I think, for 48 hours. They're maybe techno oriented, but a friend of mine bought a collection of kick drums and drum samples from them a while back, and it had the most walloping kick drums you've ever heard. They were great. Gold Baby makes samples, Hyperreal samples, BBC Radio, Bandcamp. There's tons of sample libraries for sale or for free on Bandcamp. Might be, I don't know, it might be smaller libraries, might be big libraries. I don't know on Bandcamp. The ESA and NASA both have SoundCloud pages, if I recall, where they have tons and tons of samples. Archive.org, if you guys are unfamiliar with archive.org, they have a huge library of old public domain video content, as well as you know just oodles and oodles of music, sound, live concert recordings, things like that. Heard a recording by one of my favorite jam bands from the early 2000s called Schleho on archive.org the last time I was on there. But I've sampled from there a million times. They got, old nuclear, um, nuclear warning films that the government produced and stuff like that. Um, you know, old videos on, anything, nutrition, a lot of government produced stuff that was public domain by default. And then a lot of, old material or material that maybe isn't old but is in the public domain that you can sample from, still and moving images and sound. So archive.org is one of those places that you can go and kind of dig and find all kinds of stuff. It's like the modern day crate digging in a sense. Um, yeah, I see Brian mentions the uh, uh, making a wavetable from the magnetic storm brought on from the sun. Um, that sounds like a fun wavetable experiment. Uh, yeah, there's all kinds of crazy stuff like that. But go out and find those crazy samples. Maybe that would be a good subject for a show. Also, is build your own sample pack. There's some ways that we can do that. A couple techniques that I think will make that process a lot faster and easier, and less cumbersome. So, but the modular is a great way to do that, especially if you have a DAW to record. Good excuse to go get that 90-day Ableton, whatchamacallit, trial if you haven't gotten it. Reaper, I think, is also free for 60 or 90 days right now. I think Reaper is basically free anyway. They have a nag window that comes up at the beginning asking you, hey, are you sure you don't want to pay for this? And it would probably be nice to pay for it. It's only like $60 or something like that. Something ridiculously cheap for a DAW as feature rich as Reaper. But, um, any of these things will work and will get you, I think, starting down the line towards recording sample libraries. You could even do that on the Morphogene, I think. It's easy to split up samples and recordings on the Morphogene, though it is nice to have a screen to be able to do some of the fine tuning. So, SoundForge, yeah, it's still around. I think people are probably using Adobe Audition more these days. Peak bias, Peak was the norm for a long time. I don't know. What are people using for sample editing now? I think Adobe Audition is kind of the one. They bought out Peak, I believe, and turned it into Adobe Audition. Audacity is, of course, still free and still a complete headache to use, but it's free. It does a lot of things. If you have the radio music, or if you had the radio music back in the old days before the new firmware, you had to use Audacity to prepare your samples. You had to put them in the raw file format to work with the radio music. Oh, freesound.org, great one. Freesound.org is another library. It's an online repository of samples that is all user submission based. You have to watch and make sure you read um, the what's the word I'm looking for? The rights usage rights, the copyright of those samples. Most of them are going to be Creative Commons 0 license, which means you don't have to attribute the maker, you don't have to credit them, you can tear it apart and shred it to all hell. But some are not, and so that's an important consideration. And I sit around and bash Splice a lot, but Splice, if you want to build, if you're looking for specific samples, if you're doing your production and you're like, oh geez, I really need the sound of a tugboat sinking, Splice might be the right place to go. You might be able to get a sample for relatively very cheap of something that would be really difficult to make, but I don't know if they have the sound of a tugboat sinking, but it seems like it could be a cool sound. Yeah, Audacity is a bit of a headache, but you know, it is open source and free and multi-channel, so and I believe it also has Paul stretch built into it, so you can do impossible time stretching with Audacity that you might need otherwise a specialized app to do. And when I say time stretching, I mean stretching something 10,000 times its original length. That type of extreme time stretching. So, um, okay. Well, on Thursday, we will continue with more maths. And we'll get into some of the more complicated applications of maths. Tomorrow, we'll be back here at noon once again, and we are going to make a track. We'll decide what kind of track together at the beginning of the show tomorrow, and then we're going to just take off from there and make something, and god damn it, we're going to finish it. I hope. Okay. Well, thank you guys for coming in here. Thanks for keeping me company. Ed, thanks for dropping in. Saw you pop in a few minutes ago. I really appreciate your coming through. Thanks everybody for coming in. And if you get a chance, help us spread the word. Help us get the word out about the show. Watch out for our poll on our YouTube community page. We're gonna be asking what time of day would be best for the group for us to move this to, because noon is going to stop being a handy time, unfortunately, starting next week. So we'll keep it on going. How long we streaming tomorrow? Hour and a half, maybe 2 hours. We'll see. And all the live streams, of course, go to the channel afterwards, so you can always catch up if you don't make it. But we do love to see you guys and have some chat and all of this stuff. So you can contact us at voltagecontrollab.com or at vcontrollab on Twitter or at voltagecontrollab on Instagram, or you can contact me directly at Computo on everything, at Computo on SoundCloud, on Spotify. You can go check out the Blessed Oscillator, my ambient electronic group with Dave Haro and our usually present co-host Victor, though Dancing Baby is in his seat right now. And you can always email me, voltagecontrollab@gmail.com, computo@gmail.com. All of those things and more if you can find them, but those are the kind of the main ones. So, all right. Well, thanks a million, you guys, again for coming in. Just really appreciate everybody showing up and hanging and chatting and keeping me occupied and distracted. And hopefully we're all doing the same thing for each other. And I will let you guys all know about the upcoming video game offshoot, the spin-off. And yeah, tomorrow we'll be back at noon once again. All right. Thanks again, you guys. Have a great day. Take care.